Dear colleague, it's a pity that this year the 26th FRUCT conference does not take place in person. We appreciate to have opportunity to participate in the conference online. Let me introduce Sky Company from Petrozavodsk that developed computer decision support system VideoMed with artificial intelligence. Natural language processing is one of the most exciting sub-branches of data science. It is expected that the data scientists will increasingly be able to find solutions related to use of structural text data. One of them is the feature extraction method from Russian electronic health record. Patent data in electronic health records may stand for clinical observation, find correlation, symptom association, family backstory, habit, and diseases, and then make a prediction. Many important observations in electronic health record remain unregistered in the structured record, appearing only as a free text story next to the empty fields and forms. Natural language processing methods are used for extraction feature from such cases. You can see some fragments of health examination and lab test and diagnostic in Russian electronic health record. Our model has to work with such kind of information. We are planning to extract the following information about patients. First of all, vital signs like blood pressure, heart rate, respiration rate. Second one is lab test result, glucose, cholesterol, and so on. About 15 features altogether. We use medical data from Russian electronic health record to train our model. There are anonymized unstructured text from hospital from three Russian regions. Data of patients with cardiovascular diseases aged from 40 to 80 years old. You can see how the feature extraction model works. A text string is sent to the model input, and data with the attribute name, value, and measure is extracted from the text. The algorithm consists of sequential text preprocessing, entity recognition, and entity extraction. The pipeline method is easy and convenient to use if you get data from the different sources. For this purpose, we use spicy framework in Python. An important problem with text processing for feature extraction are the large number of errors and typos. The feature extraction begins with preprocessing. Text preprocessing step including remove extra white spaces, remove special character, lowercase all text, sentence segmentation, convert number of words to numeric form, remove stop words, tokenizer, normalization, and lemmatization. For correct username integer recognition method in the feature extraction, very important to do all these steps. Next step is entity recognition. It is processing of classified name entity found in a text into predefined category, such as lab term, places, organization, date, and so on. Spicy uses a statistical model to classify a broad range of entities, including custom, such as glue for glucose, crea for creatine, and so on. Spicy is a relative new package for industrial strange natural language processing in Python. It's reasonable, low level, but very intuitive and performant. General purpose pre-trained model to predict name entity, part of the speech tags, and syntaxes dependency, but is not available for the Russian language. Anyway, you can train your own model with the name entity recognition tags for Russian language. With a spicy, you can do much more than just entity extraction. For feature extraction, the rule-based method is usually used, but over the past 2 years, the name entity recognition method has been used for this purpose. Spicy name entity recognition method, more flexible, allowed to use transform learning technology with initialize new model. The spicy pretend common used a language model objectives similar to the used in Google BERT system. To train a new model, we first need to create a pipeline that defines how we process the data. Once the model is trained, we can use it to extract entity from the unseen data. To train the model, we will need some training data. In the case of feature extraction, this would be sentences in Russian from electronic health record via pre-labeled entity. For example, our training data has a few characteristics. The entity array contains a list of tuples. Each tuple is the entity labeling from the text. Each tuple contains three elements: start of set, end of set, and entity name. The data were marked out and the basis of the data set. For training, validation, and testing were prepared. Spicy provides a way to increase the accuracy of a new model. When you create the model from scratch, we use the following algorithms for optimization. Insert the base size equal 1 and compound it to maximum determination by your data size and problem type. Use Adam solver with fixed learning rate. Use average parameter. Clip gradient by L2 norm to 1. And small data sets started in the higher dropout rate with linear decay. We developed all this feature experimentally. Python programs have always been concise and compact. In this example, it took several lines to load the model into the memory, submit a test string as the input, and get the extraction feature. That's all. Three basic metrics are used to evaluate the result of the model precision, recall, and F1. Metrics need for comparing models. In our case, we use NLP near no standard way, so we cannot compare results with other algorithms like person location extraction. Common for state-of-the-art algorithms, we need F1 bigger 90%. Metric for vital signs. Training data contain about 100 sentences for each feature. This model achieves state-of-the-art NLP performance with all metrics over 90%. Metrics for laboratory data. For triglyceride, high density lipoprotein, low density glycemic profile F1 less than 90%. It shows the problem with generalization, lack of sample. For each entity, we have less than 100 sentences, and as soon as I get more samples, we believe results will be higher. At this moment, the model is embedded in critical decision support system VideoMed and collect more medical information from new customers. Computer Decision Support System VideoMed is the first company in Russia which received registration certificate for medical device from Roszdravnadzor. Detailed information about VideoMed you can see in our website. Very important to achieve good result using this method. And from Spice, we need to train about 100 sentences per feature and extracting around 50 key features from Russian medical tests, such as electronic health record. This method shows that the extraction takes low computer resources and can be used for a large number of features and medical text. Next step is included medical ontology like SNOMED because some features need knowledge extraction method. When we need more accuracy method, we can use BERT, Roberta, XLN, and GP2 directly in our pipeline. You can see all our contacts. We'll be happy to answer your question and ready for further cooperation. Thank you for your attention.